Hello, welcome again. We are solving some questions of theory of machine. The topic is velocity and acceleration of mechanism. Question number 67 from Gates on 18 ME-02 is a rigid rod of length 1 meter is resting at angle theta 45 degree as shown in the figure. The end PU is equal to 5 meter per second to the right at the instant should be in meter per second of point Q as it moves along the wall without losing contact is option A 5, option B 6, option C 8 and option D 10. So this is the road and this is Q and it is moving with the velocity of 5 meter per second with angle 45 and this okay. So now this point Q and point P can be assumed as slider placed on that this point okay, because they are sliding respect to wall, so we can assume that a slider is at point Q and another slider is at point P. Okay, now assuming that fixed wall and floor has fixed link as one link and this has two links, this slider has two links and this slider has three links and connect this road as fourth link. Okay, so now we have to find out the velocity of this slider. Okay, to find out the velocity of point Q. Okay, so now from inspection, this will be your I13 because this is sliding and length 1 is fixed, so its I center will be at I13. Okay, it will be at infinity perpendicular to the motion of slider. Similarly, this is your link 2 and this is your link 1, so I12 will also be at infinity perpendicular to the motion of slider. Okay, so now this is the common point between 3 and 4. Okay, so this will be I34 and this is a common point between 2 and 4, so this will be your I2 point. Okay, and U is your 5 meter per second. Okay, so these are the I centers. Okay, now we have to find out the velocity of point Q, which is a common point of link 3 and link 4. Okay, so if we find out the angular velocity of link 4 and uh, and find out the point about which it is rotating or I center I14, then we can find out the velocity of point 4. So first of all we find out I center I14 or the point about which it can be assumed to be rotating. Okay, so I14 is the point where the rotation of the link about which the rotation of the link 4 takes place. Okay, so this can be find out like this. So the known first of all take known I center. We know that I12 is infinity, so for I12 there is one line and I24 is here, so for it is one line. Okay, for I43 here at this point, so for this there is one line and I41 is sorry I31 is your I31 is at infinity, so for this there is one line. So these are the four known I center. We know that I12 is at infinity and we know that I13 is at infinity and we know that I24 is at this point and we know that I34 is this point. Okay, so now our purpose is to find out I14. So as one line represents one I center, so we'll join 1 and 4. Okay, so this joining of this line completes two triangles 1 to 4 and 3 4 1. Okay, or 1 3 4. Okay, so as this triangle uh, according to Kennedy theorem, the according to Kennedy theorem, this triangle I center means I12 and I24 and I41 should lie on one line. Okay, as this triangle I center, the triangle the I centers represented by this triangle should lie on one line. So I12 and I24. Okay, so this is your I12 and this is I24. So this is the line joining I12 and I24. So here somewhere it should be I14 also. Okay, similarly for this triangle I34 and I31 line is this line. Okay, so I14 should also lie on this line. Okay, so the intersection of these two lines gives I14. So I14 is the point about which link 4 is rotating. Okay, and now we Now we know that the velocity of point P is your or velocity of slider, the slider is 4 meter per second, and point P is also lying on the slider. So it can be it is also lying on the link force. Okay, it is also lying on the it is lying on the slider as well as lying on the link force. Okay, and its velocity is 5 meter per second. Okay, so when we assume this point P on link 4 and link 4 is rotating about this point, so then the velocity of this point, by assuming the point P on this link is angular velocity of link 4 is multiplied by distance from the point of rotation. So distance of point of rotation of point P is your this distance I14 I24. So velocity of point P is your omega into I14 I24 I14 I24. Okay, so and velocity of point P is your 5. Okay, and omega is your angular velocity of link link 4. Okay, as it is rotating about this point. Okay, and this distance is this is your L, and this will be your L cos 45. Because this angle is your 45 and this angle will also be 45, so this will be your L cos 45. Okay, so omega will be your 5 by L cos 45. Okay, so now the angular velocity of link 4 is 5 by L cos 45, or L is your 1. Okay, or it will be 5 by cos 45. Okay, and the point of central rotation of 4 is this point. Okay, so angular velocity is known and point of center of rotation is known. So now we have if we are going to find out the velocity of Q, we will multiply angular velocity with this distance, that is I34 I14. Okay, so it will be VQ. Okay, VQ will be angular velocity multiplied by this distance. Okay, so this distance will be your again L sin 45, when L sin 45 and L cos 45 are same, so it will be 5 meter per second. So as this is the point velocity of point Q, and this is also the velocity of slider, because this point is also on slider and slider has same velocity at all the points, so answer is 5 meter per second.